course name is signal generation and resampling. Here we are generating the system in Matlab via data or via files, and then we have to resample that graph, or you can say that signal, so it can show what really hidden in that data. So let's start with the remaining course. You can see that at morning I already complete 79% of the course, but now there is 20, sorry, yes, there is 20% of course still remaining here, so we have to complete it. So let's see the first task, which say that instead of generating the watermark, could you see another audio file as a watermark? Okay, so here what we have to do, we have to import the audio file this into a variable name this and name the sample rate as FSB, then display the sex spectrum. Okay, the 2 minutes. Yes, that's perfect. So what we have to do here, we have to display the spectrum of the signal which we are creating. So the name of the signal is FSB, so we will write as FSB, and sorry, the sample rate is FSB, not the system. So FSB, and the name of the signal is birds. Sorry, BIRDS, birds. Now the read audio is a special type of function which used to take the data from the audio file, and the audio file on which we have to work or we have to take this data is bird call in string.mp3. As we see that we can use a read matrix function to take the data from different types of files, but for a specific type of file like mp3 or mp4, we need to use audio read function. I think for mp4 type of file there is another function, because mp4 is nothing but a video and mp3 is audio. So we will see about that later. If the course in sorry, control C, if the course introduce ourselves to the mp4 file, then it is very beneficial for myself, but if not, then I have to why it is not copying that thing. Let's see, I have to again copy it. Control C. Let's see, does it copied? Yes, copied the name, then we have to paste it. Now we have to display the spectrum. So for displaying the spectrum we have to use this specific function, which is s spectrum, sorry, p spectrum, where p is silent, I guess. Now here we just have to replace this by birds and this by FSB, which is our new sample rate. And when we click on submit, the system will run the command and we can see our new signal with new data. We just have to wait for a few seconds or a minute. So here you can see that this is our new data, and this is the spectrum graph of our signal, which is bird. The name of the signal is bird. Next, modify the bird so that its column vector contained the meaning of each row. So we have to modify it. So for modification we have to use this function, where I think that x is the name of signal and mean is just a function name, but what is meant by 2, we don't know about that. So use the code example above, but I have to store the same signal in the same name. So I will write bird equal to mean, then bracket, and what is x? X is nothing but a signal name, and we have to modify it so that column vector containing the mean of each row. So I will put on 2. Let's see. Okay, so it work, but I don't know how. So the first rule of code is, if the codes work, then you don't have to manipulate that code another time. Okay, now the next task, that is task number 3. What we have to do, use a rad function as shown above. This is a rad function where we have to assign two variable q and p. So it will has sorry, it will have fs desired slash fs current. So desired sample rate as well as the current sample rates. Okay, so this two variable will contain the value of desired sample rate by current sample rate in a rad function. And what does the rad function do? We don't know. We have to first know about the rad function. So let's see. Look in the workspace to compare the values of s sub and fsb. To use a bird as a watermark, the sample rate should match. You can resample bird, but you need to choose both p and q. This is a convection. No, this is a convenient way to find the ratio. So we have to use the rad function. So what we'll do, we will use the rad function, and where we have to store the outputs, we have to store the outputs in p and q. So let's write p comma q equals to, what is rad? I have to first learn about what is the rad. So what is rad function in Matlab signal processing? So the rad function in a Matlab is used to approximate float point number by rational function using a continuate fraction expansion. So I don't understand. So we'll see about this later. First we have to write the code, which is rad, then brackets. In that we have to write the desired sample rate and the current sample rate. So the current sample rate is fsb, right? Let's see. Yes, fsb is the current sample rate and fsup is a desired sample rate. So we will just write fsup slash fsb like this, and then we have to click on enter. So you can see the value of q and p are generated. Next step, we have to resample this. Okay, so the code for resampling is very simple, which is nothing but I guess I didn't write the resample function. Shit. Or did I write it? I don't know. I have to write it. Yes, there is not a single note that contains the resample function here. Yes, there is no single note that contains the resample function. So sorry. So what is a resample function, or what is the method to write the resample function? I have to check it first, but before that we will write it. That birds down is the variable name where we have to store the result. Okay, so we will write that, then we will use resample. Is this perfect? Yes, resample. Then we have to use this brackets, and then what we have to do, we have to choose the signal and choose the value of q and p which is already determined. So we BIRDS, birds, comma P, comma Q. And then we have to show the spectrum. So first of all, I have to write the syntax for the resample function in my notes. So to resample a signal, to resample a signal, use y equals to resample signal name, comma P, comma Q, and here P and Q. Okay, so where P and Q are what, we don't know. We will see about that later. Now we have to display this. We have to display we have to display the signal bird show. So how can we do that? We will write just bird, okay, birds down, yes, and then we click on submit. Sorry. So here the birds down, this is a column matrix where you can see the every value is 0 0 0 because we upscaled the signal, and at some point the value will be 60 or 80 or minus 80 if I'm not wrong. Then okay, we will see about that later. So this is our new signal. Is the spectrum plotted correctly? I guess it is correctly plotted, because if it's not, then there will be a major problem. We have to again find the solution and see what did we do wrong. Okay, so the problem here is that this is our desired sample rate. We didn't use this sample rate, so we have to use this sample rate here. So after this will be FSUB UP. Now it is perfect, and we will get our new power spectrum, which is okay, which is totally different from the old one, because you can see freeze equals to 755.7 is showing here, but at previous signal it shows that FRES equals to 1 point something. So there is a lot of difference here. Now what we have to do, we have to listen to the sound of a signal. How does our signal will be sound with the addition of a watermark? So for this we have to write the name of the signal, that is sound, then the name of the signal, which is birds down, and comma sampling rate is FSUP. Let's see, or let's hear the signal sound. Whoa, amazing. It is totally amazing for me to hear the signal that I have been processing till now. It is just like magic. Okay, so your goal is to generate a precise square wave signal. Okay, we have to generate a square wave signal which is a fundamental component used in a various audio synthesis scheme. Okay, the square wave signal used in a various audio synthesis schemes. Next, any periodic signal can be represented by adding a sine wave together. Okay, so for the square wave we have a special type of function and we will use that function to create a square wave. So store a sample rate of this in a variable name fs. So fs equals to 100. Then then create a 3-second time vector t using the fs function. And I'm gonna do that. I don't know. So let's see, because I don't have any idea that how can. Okay, so from this we can create time vector equals to 0 hat 0:1. Oh, okay. So time vector is nothing but the starting point and the ending point of a signal. That's why it's bit confusing for me to understand what I'm doing here. So let's start. Next, use the formula above, which is this, to create a signal named y1 where a is 1. Okay, so y1 equals to Control C, Control V, 1 by a. We have to add the multiplication sign here because Matlab is case sensitive language, that's why. Cap a equals to 1. Syntax how can I multi. Okay, so problem is that, yep, that is perfect. So let's try. Create a signal named y3 where a is 3. Plot y1 and y3. So we have to do the same thing, but because a is our global variable, we don't have to define the value of a every time. What we will do, we will just change the value of y3. But the question says that here the value of a equals to 3. So I think that we have to enter and caps equals to 3. Then we have to plot the sum of y1 and y3 versus t. I think this will be perfect. Let's see. We will get some type of syntax error because we defined the value of oh, it is y3 not y2. Let's see. Okay, so we get the perfect signal here. What's happened is, for this task, first the value of a equals to 1, and for this task the value of a equals to 3, which is store the sample rate of 200 Hz in a variable named this. So this is a variable name. We have to contain the sample rate of 200 Hz. Use the rad function as shown above to get the rational fraction between the desired sample rate f. So we have to again use this in this task, and here the desired value is, I guess, FSUP, and the current value is FS. Let's click on submit. Yeah, the value of key P and Q is perfectly generated. Now resample the square wave this using P and Q. Name the result as square up and display the spectrum of the signal. So again, for the resampling we have to use the variable name where we have to store the data. Then we have to write the resample function, which is this, and after that we have to write the name of the signal, and the name of the signal is, what is the name of the signal? Y1 plus y3, y1 plus y3, comma FSUP, which is our desired sample rate. Then we have to use the P spectrum. Then the name of the new variable is SQU square up, comma FSUP. Now let's see. So there's something that give us, okay, so the problem here is that it doesn't mention the name of the signal here. So the name of the signal is, no, we already mentioned the name of the signal. You can see doesn't mention the P value of P and Q, P comma Q. So you can see this is our beautiful spectrum of the signal that we have created, and it doesn't have any type of error. Let's listen to the sound, or you can say a beautiful sound of our signal, because why not? Sound up, comma desired sample rate, which is this. Let's hear beautiful sound of a signal. Okay, so there is some problem which says that sound sorry, error sound line, the sample rate provided is, okay, so what we have to use here is FS, not, no, S sound SQURE up is perfect. Why can I'm getting this error? So the sample is provided to all of this, so we have to change the sample rate, I guess. Let's again run the, again we get the same problem. Let's see the sound function, which is SOU. Square up, comma sub. Why we are getting this type of error again and again? To generate a square wave with more harmonics used. Okay, so understand now. The problem here, it is saying or telling to us that the wave does not have enough sample rate to generate a sound. If I am right, then let's ask to Leo. Leo is a fast AI. Okay, so when I write this code, that is the sound function to listen to the audio of a signal, that I have created, then I get the above error. So explain me why. Let's see. Of error explanation. The error occur because the sound function in Matlab requires the sample rate this to be with specific to be within a specific range, typically 1000 to this. As per Matlab restriction, the this sample rate is below the required range. Okay, I understand that. So now I know why we can't hear to the sound, because the sample rate need at least to be above 1000, and here we specified that the sample rate is equals to 200. That's why. So I think with this we have completed our course, and this is just a review and overview of a course which I have already taken very seriously. So I don't think I have to again exit the course. Okay, leave. So from this certificate I can complete my collection of MadWorks certificate up to 25. Okay, this is report. I have to okay, and then this. So with this I have successfully completed a 50 certificate. Sorry, I have successfully taken the 50 certificates with, obviously, with skills. Report 25. So what I'm saying is that with this I have successfully taken a 50 certificate from a genuine website known as Matwork Training Services. So I think that's all for today. We will meet again very soon, when the urge in my body says that we have to learn the Matlab. So